Azure SQL Database is Microsoft's fully managed relational database service built on the SQL Server engine. Every feature you already know from SQL Server, T-SQL, stored procedures, views, indexes, transactions works exactly the same way. The difference is that you never touch the database server itself. Microsoft handles operating system updates, SQL Server version patches, hardware maintenance, and automatic backups. If the hardware your database runs on fails, Azure automatically moves it to healthy hardware with no data loss. The 99.99% SLA is not a goal, it is a contractual guarantee backed by zone-redundant infrastructure. The service comes in 3 deployment options. Single database is an isolated database with its own compute and storage, the right choice for most independent applications. Elastic Pool lets multiple databases share a pool of compute resources, which reduces cost when databases have variable and non-overlapping peak usage patterns. SQL Managed Instance provides near-complete SQL Server compatibility for lift and shift migrations where you rely on features not available in single database, like SQL Server Agent, cross-database queries, or linked servers. The honest rule: if you are building a new application and need a relational database, start with single database. If you are migrating an existing SQL Server application with complex dependencies, evaluate Managed Instance. Choosing between deployment options is the first decision you make, and getting it wrong is expensive to undo. Let me give you the real criteria. Single database is the default choice for new applications. Each database has its own compute tier, its own storage, and is managed independently. You scale it up or down without affecting anything else. When you have one application with one database, this is always the right answer. Elastic Pool solves a specific problem. You have many databases, think SaaS applications with one database per tenant, and they do not all peak at the same time. Instead of paying for dedicated compute for each database, they share a pool. If your 50-tenant databases each peak at different times, a pool with compute sized for 5 concurrent peaks costs far less than 50 individual databases. SQL Managed Instance is the migration path. It supports features single database intentionally omits SQL Server Agent for scheduled jobs, cross-database queries within the instance, linked servers to other data sources, and service broker. It deploys into your VNet natively, which single database does not. If your migration assessment flags these features as dependencies, use Managed Instance. Serverless is a pricing tier for single database where compute scales to 0 when the database is idle, and you pay only for the seconds it is active. Use it for development databases or applications with sporadic usage patterns where paying for unused compute is wasteful. The purchasing model determines how you size and pay for your database compute. Understanding this prevents overpaying or undersizing. The DTU model, Database Transaction Units, bundles CPU, memory, and I/O into a single opaque number. A 100 DTU database gets a fixed ratio of all 3 resources. This model is simple but inflexible. You cannot adjust the CPU to memory ratio. Microsoft has indicated the DTU model is legacy and recommends vCore for all new deployments. The vCore model lets you choose the number of virtual cores and a hardware generation, and Azure maps this to memory and storage automatically. You can also choose the service tier independently. This transparency lets you right-size the database and makes cost estimation straightforward. General purpose is the right tier for the majority of workloads. It uses remote storage with a 5 to 7 millisecond I/O latency, which is acceptable for most OLTP and reporting workloads. You get 99.99% SLA and can enable zone redundancy. Business Critical uses local SSD storage directly attached to the compute node, giving you under 1 millisecond I/O latency. It also includes a built-in read replica at no extra charge, a second instance your application can connect to for read-heavy queries, reducing load on the primary. Use Business Critical for latency-sensitive transactional applications. For the Azure Hybrid benefit, if your organization has existing SQL Server licenses with software assurance, you can apply them to Azure SQL Database and save up to 55% on the vCore compute cost. By default, Azure SQL Database is accessible over the Internet on a public endpoint, but protected by a firewall that blocks all connections until you explicitly allow them. Understanding the connectivity model is critical before you ship to production. The server-level firewall controls which IP addresses can reach your SQL Server, the logical server that hosts your databases. You can allow individual IP addresses, IP ranges, or enable the Azure Services exception which allows other Azure resources in your subscription to connect. The Azure Services exception is convenient but broad. Prefer explicit IP rules or private endpoints for production. Private endpoint is the production standard. It provisions a network interface with a private IP address inside your virtual network, so your database is reachable only from within your VNet or connected networks. Public access can then be disabled entirely. When combined with App Service VNet integration or a private subnet for your compute, your database never appears on the public internet. Your connection string must always specify encrypt equals true and trust server certificate equals false. These settings enforce TLS encryption and validate the server certificate, preventing man-in-the-middle attacks. Any driver or application framework that connects to Azure SQL Database without encryption is transmitting credentials and data in plaintext, a critical security failure. Check your connection strings before deploying to production. Authentication to Azure SQL Database has two modes, and the difference matters significantly for security posture. SQL authentication stores usernames and passwords directly in the database. Credentials are independent of your Azure identity system. If an employee leaves, you must manually revoke their database password. Passwords can be shared, reused, or leaked. SQL authentication is acceptable for application service accounts when used with strong, rotated passwords, but it should never be the primary authentication method for human access. Azure Active Directory Authentication, now called Microsoft Entra ID Authentication, lets users and applications authenticate using their Azure AD identity. For human access, this means single sign-on using their corporate credentials. If someone's account is disabled in Azure AD when they leave the organization, their database access is automatically revoked. You can enforce multi-factor authentication and conditional access policies on database connections using the same policies you apply to Office 365 and other services. Managed identity is the most secure option for application authentication. Your app service, Azure function, or other compute resource has an assigned identity. You grant that identity access to the database. The application connects without storing any password. There is no secret to leak, rotate, or accidentally commit to a Git repository. This is the pattern you should use for all new applications connecting to Azure SQL Database. Configure it once and eliminate an entire class of credential management problems. Azure SQL Database runs automatic backups continuously. You cannot disable them and you do not need to configure them. Understanding the backup model helps you set retention correctly and know what you can recover from. Full backups run once per week and capture the complete database. Differential backups run daily and capture changes since the last full backup. Transaction log backups run every 5 to 12 minutes depending on the workload and capture every committed transaction. Together, these three backup types enable point-in-time recovery to any second within the retention window. The default retention period is 7 days on the basic tier and up to 35 days on standard, premium, and vCore service tiers. Configure the maximum retention your tier supports for production databases. 35 days costs nothing extra and gives you 5 weeks of recovery options. Point-in-time restore creates a new database from any backup point within the retention window. You restore to a new database name, validate the data, and then swap your application connection string if needed. The original database is not modified. Restore is always additive. For compliance and regulatory requirements with retention beyond 35 days, configure long-term retention. This policy copies weekly full backups to Azure Blob Storage with configurable retention of up to 10 years. The storage cost is minimal, backups compress heavily, and the policy runs automatically once configured. Backup storage is geo-redundant by default, meaning your backups are replicated to the paired Azure region. Even a complete regional disaster does not destroy your backup data. High availability in Azure SQL Database works at two levels, within a region and across regions. Understanding both determines your actual disaster recovery capability. Within a region, Azure SQL Database uses a high availability architecture where compute and storage are separated. If the compute node fails, Azure automatically provisions a new one and attaches it to the existing storage within seconds. For general purpose, this failover takes 20 to 30 seconds. For business critical, a secondary replica is always running in standby and failover takes under 1 second. Zone redundant configuration spreads the database replicas across 3 availability zones in the region. This protects against data center level failures. A power outage or cooling failure in one zone does not affect your database. Enable zone redundancy for any production database. It requires standard or premium tier or the general purpose or business critical vCore tiers. Active Geo-Replication creates readable secondary replicas in up to 4 other Azure regions. The secondary databases are continuously synchronized from the primary with replication latency under 5 seconds. Secondaries are readable. Your application can offload read-heavy queries to the secondary to reduce load on the primary. In a disaster, you manually initiate a failover to promote the secondary to primary. Auto failover groups extend Active Geo-Replication with automatic failover. The group provides a single read-write connection string endpoint and a separate read-only endpoint. If the primary region fails, Azure automatically promotes the secondary and updates DNS. Your application reconnects to the same connection string with no code changes required. Scaling Azure SQL Database is intentionally simple compared to managing SQL Server yourself, but there are important nuances to understand for each scenario. Scaling compute, changing the service tier or vCore count, is an online operation. Azure provisions the new compute size, copies data to it, and then performs a brief connection cutover, typically lasting under 30 seconds. For most applications, this interruption is acceptable during a maintenance window. Build retry logic into your database connection code so a brief disconnect during scaling does not cause application errors. This is good practice regardless of scaling. Storage scales independently of compute. By default, storage autogrows as your data fills the allocated space. You can also set the maximum database size explicitly. Storage scaling never causes downtime or reconnections. There is no way to reduce allocated storage on Azure SQL Database once it has been expanded. Size up carefully and monitor actual storage consumption before allocating maximum sizes. The business critical tier includes a built-in read replica accessible via the application intent equals read-only connection string parameter. This secondary is synchronous. It has the same data as the primary with negligible lag, and connecting to it offloads read workloads without any additional cost. If your application runs frequent analytical queries alongside OLTP workloads, routing reads to the secondary can significantly reduce primary load. For serverless compute, you set a minimum and maximum vCore range. Azure scales within that range based on CPU demand and pauses compute entirely when the database is idle for a configurable delay. Serverless is cost-effective for development databases, internal tools, and applications with unpredictable or highly variable workloads. Azure SQL Database has multiple security layers that apply at different points in the data lifecycle. Understanding which layer protects what prevents both over-reliance on one control and gaps in coverage. Transparent data encryption encrypts the database files on disk automatically. It is enabled by default on all new Azure SQL databases and cannot be disabled. TDE protects against someone stealing the physical storage media or backup files. The data is unreadable without the encryption key. By default, Microsoft manages the TDE key. If your compliance requirements mandate customer-managed keys, you can store the TDE protector in Azure Key Vault and retain control over key rotation and revocation. Always Encrypted is column-level encryption where the encryption and decryption happen in your application client, not in the database engine. The database server stores and retrieves encrypted ciphertext but never sees the plaintext values. This protects data even from database administrators. A DBA querying the database sees encrypted bytes, not actual credit card numbers or social security numbers. Implement Always Encrypted for columns containing regulated data where insider threat is a concern. Dynamic data masking does not encrypt data, it masks it in query results for non-privileged users. A credit card column might show as XXXXXXXXXXXXX1234 to a support agent while showing the full number to billing systems. Masking is enforced at the query level and requires no application changes. Microsoft Defender for SQL monitors your database for anomalous behavior, unusual query patterns that suggest SQL injection, access from unexpected locations, credential brute force attempts, and data exfiltration patterns. It sends alerts to your security contact and integrates with Microsoft Defender for cloud. Enable it on all production databases. Observability for Azure SQL Database has several layers. The ones developers most frequently overlook are also the most actionable. Query Performance Insight is built into the Azure portal and surfaces the queries consuming the most CPU, I/O, and duration over configurable time windows. This view answers the most common database performance question, which queries are slow, without requiring any profiling setup or third-party tools. Check it before vertical scaling. In most cases, adding an index or rewriting one query delivers more improvement than upgrading to a larger service tier. Intelligent Insights uses built-in intelligence to detect performance anomalies automatically. When query duration degrades significantly compared to baseline, when the plan degrades due to statistic staleness, or when unusual wait patterns emerge, Intelligent Insights generates a diagnostic log entry with a description of the issue, the affected queries, and recommended actions. It does not require configuration, it monitors continuously in the background. Azure Monitor collects CPU percentage, DTU or vCore utilization, storage percentage, successful and failed connections, and deadlock counts automatically. Set alerts on these metrics so you receive notifications before users do. A CPU alert at 80% gives you time to investigate before the database saturates at 100%. Diagnostic logging streams detail operational data to log analytics, Event Hub, or storage. The most valuable categories are SQL Insights for wait statistics and query store data, errors for connection failures and query timeouts, and query store runtime statistics for historical query performance. Enable these from the diagnostics settings blade on day 1. Retroactive data is not available, so you want the full history when an incident occurs. Think through this carefully. Active Geo-Replication creates the readable secondary and enables manual failover, but it gives you two separate connection strings. Your application must implement logic to switch between them on failover. That is code you have to write and maintain. Auto failover groups sit on top of Active Geo-Replication and solve the connection string problem. The group exposes a single read-write listener endpoint, something like yourgroup.database.windows.net, that always points to the current primary. When failover occurs, Azure updates the DNS record behind that endpoint to point at the new primary. Your application reconnects to the same connection string and everything works without code changes. The group also provides a read-only listener endpoint for routing read queries to the secondary region, giving you geographic read distribution as a bonus. Recovery objectives. With auto failover groups, the recovery point objective is under 5 seconds of data loss and the recovery time objective is under 30 seconds for automatic failover. For most production applications, this meets or exceeds the availability requirements. Active recall. The difference between active geo-replication and auto failover groups is the automatic DNS failover in single connection string, not the underlying replication mechanism.